Every Fiori app you launch starts with an odata call. That single request passes through the Internet Communication Framework, hits the SAP gateway, executes a data provider class or core data services view, and returns JSON to the browser. If any link in that chain is misconfigured, you get one of two outcomes: a vulnerability that exposes data to unauthorized users, or a policy that leaves your users staring at a spinner. In this session, you will learn how to lock down OData services with proper Internet Communication Framework node security and scope-based authorization, then tune them for performance using batch optimization, expand strategies, and gateway timeout configuration.
Let us start with how an OData service comes to life. You build a data model, either a traditional gateway builder model in transaction SGWMD or a core data services view with OData annotations. Next, you register and activate the service in transaction /IWFND/maint_service. This step creates an Internet Communication Framework node under /SAP/OPU/OData. That node is the entry point for your service, and every HTTP request to your service enters through it. If you skip proper activation or leave test services registered in production, you create an attack surface. Always deactivate services that are no longer in use and audit your service catalog quarterly.
The Internet Communication Framework node is your gateway. Each OData service maps to a node under /SAP/OPU/OData/SAP. You control access at this node level through transaction SICF. The key settings are the authentication method, basic, certificate, or SAML, and the service user. Use a system or communication user with minimal authorizations. Also check the node's logon data. If it defaults to a user with SAP_all, every request inherits full authorization regardless of the end user's role. This is a gaping security hole in Fiori landscapes. If your OData services are backed by core data services views, you have a second authorization layer. CDS views support the annotation at accessControl.AuthorizationCheck, which can be set to check, not_required, or not_allowed. When set to check, the runtime enforces a data control language, a DCL file, that defines which rows the user can see based on their role. This is built into the data layer. For example, a DCL for a purchase order view might restrict visibility to orders from the user's assigned purchasing organization. Without DCL enforcement, any user who can reach the OData service can read all rows in the underlying entity. Always set authorization check to check for any CDS view exposed as an OData service. Now let us shift to performance. The $expand query option lets you retrieve related entities in a single request, for example, a purchase order header with all its line items. This sounds efficient, but it comes with a trap, blowing through your gateway timeout. The alternative is multiple targeted requests, one for the header, one for items, one for conditions. This adds HTTP round trips, but keeps each query lightweight. The right choice depends on your data volume. For entities with fewer than 50 child records, expand is usually faster. Above that threshold, test both approaches and measure gateway response times before committing. Batch requests let you bundle multiple OData operations into the UI5 framework does this automatically when you configure the OData model with group IDs. But batch is not free. Each operation inside the batch still executes sequentially on the gateway, unless you enable parallel processing in the service configuration. Check your service metadata. If the service supports change sets, operations within a change set can run in a single logical unit of work. Reads can often run in parallel, while writes need transactional consistency. A well-structured batch strategy can cut the number of HTTP round trips by 70 to 80% without any back-end code changes. Gateway timeouts are the bane of Fiori user experience. The default timeout for the ICF handler is 60 seconds. If your odata call takes 61 seconds, the user sees a generic error with no useful context. You can tune timeouts at 3 levels: the ICF service level in transaction SICF, the odata service level in /IWFND_maint_service, and the HTTP connection level in transaction SM59. Be deliberate. Over timeouts often mask a slow query. Use timeout tuning as a safety net, not a fix. If a request regularly takes more than 30 seconds, optimize the query first. When something goes wrong, 2 transactions are your best friends. /IWFND/error_log captures every gateway error with timestamps, user IDs, and HTTP status codes. Filter by time range and service name to isolate the problem. For deeper analysis, /IWFND/traces lets you record request-level traces, the full HTTP request in response, including headers, payload, and back-end execution time. Leaving traces on for all users in production generates enormous logs and degrades performance. Think of traces like a debugger breakpoint, precise, temporary, and removed after use.